Green light, fan is on, and I'm in 600, 500. Let me see, it goes down to 400, 800. It's good. Hey, what's up, guys? This is Juan from Engineering Room Mac Services, and we have one more video today. So today we have MacBook Air. We'll still have way more MacBooks Air to repair, but I'm gonna be showing each different issue that we're having, so you guys can learn a little bit more. So the problem with this computer is it doesn't power on. Okay, and let me show you here. No, I think this one, yes. So I have my charger connected, okay, and it's taking 164, but it's taking it from the first second I connected. So we know those 11 millivolts I have there is because it's what consumes, is what my power supply. The cable I have, the power, this cable, it have a small display, and that display is showing me the voltage, the current that is taking it. So right now it had LED, so it takes 11 millivolts. So when I connect the power supply, it normally does go like 20, 30, 50, and then 100, 500, and something like that. This one goes for the first second to 171. Try one more time. Or didn't? Oh, it's not. There you go. 171. One more time. 171. 171. So what this is telling me is telling me that there's a short circuit somewhere in my logic board. It have to be related with PPDC in G3 Hot or PPDC in ISOL or even PPBot. It have to be related those boards because it's from the first second. Boom, 171, 172, and then it moves a little, and that's gonna be on the 160. Okay, so what we're gonna do, we're gonna try to get, we're gonna use our thermal camera to see if it's gonna help us to find it, and if we find it, we're gonna check how or why, how we can check it if we don't have a thermal camera. So let's go with the first thing. Let's go with the thermal camera. ¿Hablaste? Okay. So I'm gonna connect it. I'm gonna be showing you guys the thermal camera. Let me try. Let me see how, like this. Okay. So this is where we connect the flex. I tell you guys, this is my finger. Okay, wait. This is my finger, right? So I move. Okay, there you go. I'm checking the whole board. This is the CPU. You see, CPU is not hitting. It's blue. And the moving. Okay, look this part. What are these capacitors? It's telling me that those, but it's telling me that it's an 90 Fahrenheit, 118 Fahrenheit. Okay, now what I'm gonna do right now is I'm gonna turn off my power supply. If we will see if that goes away. You see, power supply is off. You can check this image on my phone with the current at the voltage from the, and look, 106, 105. Now it's on right now, and it's back. Okay, so what's on the other side? Oh my god. Okay, look, U7100. Boom. Off, on, off, on. There you go. There you go. That's my problem. Let me take a video of this. There you go. So that's where my problem is. Now, what we're going to check right now is why. Is the now, just to be 100% sure, I don't have to, but I already know what my problem is. And I'm gonna show you this. Okay, I'm gonna put a little bit of this liquid, and then we're gonna check how. Oh, let me show you here. How fast it's gonna evaporate. Not fast enough. So it's not that. You see? So I'm putting liquid. Oh, you see that point? Look. You see it right away. Okay. So we already found the short circuit. Now it's hot. Actually, it's not that much. It's not that hot. I can feel it with my finger. I have the glove, of course. I have another one over here. Let me see this one. With this one goes better. Yep. With this one goes better. So what we're gonna check is the IC by itself, how which values is dropping down, and if you don't have a thermal camera, how you can find this issue. So the first thing we know, we connect, and then let's say that you don't have a power supply. So like this, I'm not showing anything. So if you don't have a power supply, how you know you have a short circuit? You just know that your charger is not, let me see if it's giving you, your charger is not giving you light. I have the charger connected, I don't have light. And if you put your fingers, you can't feel anything. At this point, you just say, okay, my phone, my board is not powering on, maybe it's my charger, maybe it's whatever. So we're gonna check. The first thing we need to check is power analysis. Okay, this is power analysis. Okay, water and power analysis. Which one is the first line we need to check? PP bus G3 hot. So I'm gonna check PP bus G3 hot in my fuse, F7140. Okay, so I'm going to check F7140, and we got here we got nothing. Let me see, is that connected? Yes, nothing. I got nothing. Nothing here, and nothing here. Okay, and then okay, I don't have PP bus G3 hot. I mean, I don't have, yeah, PP bus G3 hot. So what, I don't have PP bus G3 hot. So what I need to check after, if you don't have PP bus G3 hot, don't test PP bus S5HS or any of the PP bus S5HS. Don't test it. Go to PPDC in G3 hot directly. Okay, let's take it, bro. Let's check PP bus G3 hot directly. We go over here, and we're gonna check them right here. And how much we got the PPDC in G3 hot? 16.7 volts. Now, then let's go to the ISO. And it's R7005. Right here, and we got 1670. So I'm not gonna check all these. I'm just going directly to PP3B42 G3 hot, and we are present. PP3B42 G3 hot is the next one. So I already know my DC G3 hot, ISO, and PP3B42 G3 hot is present. So the one I don't have present is PP bus. Who creates PP bus? At this point, I'm not even gonna check PPB-RTC G3 hot because I'm not worried about the RTC signals. I'm worried about power. I don't have PP bus, so I'm gonna check my PP bus G3 hot. Okay, so I'm going here. I'm going to my PP bus, and who create PP bus G3 hot? Just found it. Okay, to the system. So people have already told several times about this. It's created between U7100 and inrush limiter. So I know PPDC in G3 hot is present. I know the PPC in G3 hot isol is present, these two signals. And I know PP3B42 is present. I know all that is present. So now what I need to check, what I don't have this guy present. I already checked F7140, and 7140 is both sides is no at all voltage. Okay, so let's go to L7130. 7130 is this big guy over here. And we have in F7130, we have nothing, 1.7 millivolts. You see, nothing. Okay, so Q7130 is right here. He's receiving, he should be receiving 2349. He should be receiving 12 volts or 16 volts. Let me check. Which one is he? This guy over here, and he got 9.32. Is that enough? It's not enough. So what I need, why is getting that instead of 16? Very good question. How we R7186. Okay, R7186 should be on 0.1. Is this one? This is 0.1, I think. $60.71. So on the 0.2, this guy should be 0, so you can push this power down and create PPDC in G3 hot inrush, but it's not. So both ties, they are high, but high current, high voltage. I mean, 15 and 15. So it means that inrush limiter is not opening. Why U7100 is not dropping that line down? So what I need to do, I need to check U7100 power. So what we're gonna get, we're gonna get the AC in, and we're gonna check DC in. We go to D7001 and I check PPDC in G3 hold ISO. I know that one is good. 1669. Now I'm gonna check the leg 3. PP chart DC in DR, and that one is good too. Then I have R7005. How much is R7005? Is 20 volts. So I should have almost the same value, the same voltage in both sides of the resistor. So on this one I have 1635. On this one should have the same. And I have 13.5. Okay, so I have 13.5. So what it means? It means we already know there's a short circuit, but in case you don't know, the first thing you are going to check is you're going to check R7105, and you know is 20 volts, 20 ohms. I mean, my bad. So 20 ohms right here, and we got 20 volts. So why, if it's only 20 volts, I have 16 and 13? So probably the IC U7100 is consuming or is shorted in one of the legs. So what we're gonna do right now is we're gonna check if any of these legs is shorted to ground or too low. Okay, I'm gonna show this. So I'm checking if I'm gonna check if any of these guys is shorted to ground. This one is. It's not shorted to ground. It's a 112 millivolts. I need to show you no voltage. I need to show you power supply now here. Okay, in diode mode, I'm checking this pad. I have 112, and then I have this one. It's good. Let me see if anything else is low over here. No. And I have this one. How much is this one? 125, 125. They're connected. Okay, so it's not shorted to ground. And then over here, this guy. This one is shorted to ground. Okay. This part. This is 1, 2, 3. 1. Which one is that one? Okay. Let's go back to the schematics, and it's showing me that this pad, this one, no, this one. Charge U gate. Charge U gate is to ground. Okay, charge U gate is shorted to ground. And this one is not. I think this is ground, yes. And then I have this one and charge U gate. Okay, so wait, we're checking. Which one is this one? So I have charge U gate and charge boot. Both of these ones are ground, are 0 and 0. Okay, so let me check these two to where it goes. Okay, Q7130, and the other one, charge U gate goes to Q7130. Okay, so there's a big chance to be Q7130. Now, before I go, well, at this point, let me remove it. Oh, my bad. At this point, let me remove Q7130. I see some sign of water over here. Let's remove it, then we're gonna test our lines again. Oh, I need to clean and fix a little with this keyword connector, but that's not a problem right now. ¿Qué pasa con el jean? Ya lo voy a armar. Okay, now we'll remove Q7130, right? Now we're gonna check those lines again. And we got this one still low, and this one still low. And they go, this is a simple path. They go to U7100 to Q7130. So we're gonna do, I'm gonna very quick check with another logic board if those paths, they are that low. This is the other board. I don't know what's the problem with this one. No, and no. So what it means my U7100 is the one that is shorted to ground. You see, this is how you can get in this specific issue, in this model, how we got that that IC is shorted to ground without using a thermal camera or without using any liquid, just testing. Now, in general, this is how you can get that an IC is shorted to ground. Of course, not always going to be like that. It can be any other way. It can be the Q7130. It can be a capacitor. It can be anything. But in this case, that's a problem. So let's remove it. let's remove it, and then we're gonna check the pads again. We're gonna replace it with another Q7130, and then we are going to test it again. Okay, it's out. Now let's test it. Not shorted and not shorted anymore. That was our problem. Let me get a donor board with U7100. No, that's gonna be hard to get. Let me check this one here. Yes. So let me put the Q7130 first. Let me put this guy first. You know what? I think it looks better when I add my ugly face to this. There you go. Looks better. Okay. Okay, Q7130 is back. Move it too fast. Be careful. And then let's take U7100 for this donor board. Okay. So my U7100 is in place. So what we're gonna do right now, we are gonna let it cool down a second. Then we're gonna clean it, and then we're going to test it. And I hope everything goes well. From the first moment, we knew that the problem was between the U7100. I won't say that I knew it wasn't. It could be a pad coming to it, or a pad that's going in front of it. It showed at some point, but it's reflecting in the U7100. So at that point, it would take, I don't know, like 5 minutes. Just take it out, test, everything is okay, put a new one and gone. That's what will me, if I wasn't recording, that's what I should do. Right now, I want to show, if you don't have a thermal camera, or if you don't have a liquid that you can put, if you have alcohol, sometimes it doesn't work, it doesn't show it like that. That's why I decided to go the whole path and show you how you can find a short circuit in related to a PP bus line. Okay, let me clean it. And now we are going to test it. I put my fan. Remember that this board was going directly to 171 milliamps. When I connect the power, it wasn't cycling, just going directly. Let's check right now. Green light, fan is on, and I'm at 600, 500. Let me see, it goes down to 400, 800. It's good. And the CPU is going up. You saw those milliamp, 800 milliamps, and then 400 milliamps. There you go. Oh, you guys aren't seeing it. Let me disconnect it and connect it. Come on. Again. We go, you see 700, 800, and then 400. 800, 700, 400. There you go. And now at any second, I'm going to have a CPU activity. There you go. That's it, guys. Another repair, simple repair. If you understand what you need to use, which technique you need to use, and what are you looking for. Okay. So another A1466 repair. Problem with this one was a short circuit on PP positive hot because U7100 was shorted to ground. Okay. That's it, guys. See you next time. Bye.